This video is going to explain how to solve quadratics by completing the square. In an earlier video, we learned how to convert quadratics into vertex form by completing the square. So we're going to follow the same process, but instead of converting it to vertex form, we're going to solve for x. Completing the square is a useful tool when your a value is already equal to 1 and your b value is equal to an even number. If these two things are not true, then completing the square would not be the best method to use. The first example we're going to look at, we have x squared plus 2x minus 3 equals 0. We already have it in standard form. Our a value is 1, and our bx value is a 2, so that is an even number. That means that completing the square will actually be a viable method to solve this for x. The first step when completing the square is to isolate your constant. So we have that negative 3. We want to move this negative 3 constant to the other side of our equals. Because it's already equal to 0, we could have skipped the changing it to equal to 0 from f of x because it's already equal to 0. So we're to isolate our constant. We have x squared plus 2x. We're going to add 3 to both sides, so we'll have equal to a positive 3. The next part of completing the square is where we use the workbox. Now the workbox was that rectangular box where we take half of b and square it. So our b value, this is one of the reasons why we want b to be even, so we can take half of it. Our b value is the 2, so we're going to take half of 2. And again, this, from a previous video, I explained that whatever this value is, 2 divided by 2, is going to go into this next set of parentheses. So 2 divided by 2 is 1. Now I can square it. 1 squared should give us a positive 1. And as always, this value should be positive because anytime we square a real value, it will give us a positive answer. The next step was to add the 1 to both sides of our equations. So I add this 1 to both sides of our equation. So I should have x squared plus 2x and then plus 1, because I'm adding the 1 over here, and it's a constant, is equal to, I have to add the 1 to the 3. So we have 3 plus 1, that's equal to 4. The next step in completing the square was to factor the trinomial. So to factor the trinomial, we should end up with parentheses squared. Now we've created a perfect square trinomial, so we should be able to take the square root of x squared, which is x, take the square root of the 1, which is 1, and we have a positive sign in the middle, so we should have a plus 1. As always, back from completing the square, whatever your half of b is, should be the same number inside of your parentheses. So it was a 1, and we have a 1 here, so that was good. Equals, we still have equal to 4. Now this is where we can do one of two things. From here we can convert it back into vertex form, or we could solve for the variable x. Now since we're solving by completing the square, we do want to solve it. But this is where it would converge to two different possibilities. So I'm going to draw my two arrows to show that there are two possibilities. Now the first possibility was if I had asked if the directions were to convert to vertex form. And the second possibility is if it was to say to solve. Now, just as a recap, converting to vertex form is actually taking the problem and moving everything to the left of the equal sign. So that's why it's going to the left. Solving is so that we can get everything away from the x, moving everything to the right of the equal sign, which is why this is on the right-hand side. I'm going to take this problem. I have parentheses x plus 1 parentheses squared equals 4. I'm going to have it on both, because this is where we diverge with the two directions. So convert to vertex form, we would subtract the 4 to both sides, because we have to get it back into equal to 0. So it ended up with parentheses x plus 1 parentheses squared minus 4 equals to 0. And then we would just change this back into a regular function. So then in vertex form, it would be written as y equals parentheses x plus 1 parentheses squared minus 4, no longer equal to 0. This is if the question asks you to convert it to vertex form. So from here, you have two possibilities, convert to vertex form or to solve. Now when we're solving, which is actually what we're doing, I wanted to recap what you would do. You'd move everything to the left to convert to vertex form, which is why I put this on the left-hand side. Our problem is asking us to solve, so we want to move everything to the right. This solve would mean you want to have x equals in the end. Now this actually looks very similar to solving by square roots. This is exactly why we have this. Square roots is used when there's only one letter x in the problem, and we do have only one x in the problem. We have this one x right here, so we want to get everything away from the x. We have that plus 1 in the square. Since the plus 1 is inside the parentheses, I cannot deal with that yet, so I have to get rid of the square first. To do that, we would take the square root of both sides. We would take the square root of both sides. The square root of the left and the square root of the right. Now, you should always have two answers when you solve quadratics. So when you take the square root of a square, this will go away because they cancel each other out. They're inverses of each other. And it will also get rid of the parentheses. So we'll end up having x plus 1 equals. Now, because we're taking the square root of a value, we have to remember to put that plus or minus in front of our number. The square root of 4 is a 2. Now what we would do, if we want to still get that x by itself, we have to subtract the 1. Now that the parentheses are gone, we can deal with the 1. We want to subtract the 1 away. So we'll have x equals. Now since we're moving that negative 1, I want to go ahead and write this out correctly. That plus or minus has to stay with the 2. So it's really a negative 1 plus or minus 2. But because it's negative 1 plus or minus 2, we should still have two answers. And these are rational numbers. So when we separate them, we'll have x equals negative 1 plus 2 and x equals negative 1 minus 2. Now we can plug these into our calculator or we can just solve them like normal. X equals negative 1 plus 2 is a positive 1. And then negative 1 minus 2, x is equal to a negative 3. And we can actually plug this back into our original problem, all the way back at the top, and to see if it will give us the correct answer. So I'm going to use the x equals 1. I'm going to use the 1 first. So I take my calculator. I'm going to use the positive 1 first. So I'm going to do parentheses, positive 1, close parentheses, squared, plus 2 times, again I'm using the x of 1. Then I'm closing my parentheses. Now I'm going to put minus 3. When I press enter, it should give me a 0. It does. So x equals positive 1 works. Then I'm going to check the negative 3, doing the same thing. So parentheses, negative 3, parentheses, squared, plus 2, parentheses, negative 3, close parentheses, minus 3. And again, when I press enter, it should give me a 0. And it does. So our two solutions of 1 and negative 3 are accurate. We cannot leave it as negative 1 plus or minus 2 because these are rational answers. Now again, the reason why we understand this, why we're moving everything to the right, is because we're solving it. Converting to vertex form is moving everything to the left. So it is imperative that you read which directions it's asking for completing the square, because there are two different possibilities you could have.